Alright, hi you guys, welcome. This is AP Calculus ABA, and we're talking about the product and quotient rules and higher order derivatives. Okay, so just taking a look at it right here, let's go to, I found this great little thing on basic derivative rules from Brown College back in Massachusetts. Okay, so the product rule. Now the product rule is the derivative of the product of two functions is not the product of the function's derivatives, rather is described by the equation below. Okay, so in other words, when I do the derivative of a product of two functions, and you have to always think, am I dealing with two functions or am I dealing with a constant in a function? Okay, alright, you're going to take the first function, leave it alone, and times it by the derivative of the second, plus the second function times the derivative of the first. Okay? Alright, now the explanation is given by the difference quotient, so if you'd like to pause the video and look at this, go ahead. I'm going to go ahead and move on to an actual derivative that we're going to work with. Okay? So find the derivative of f of x equals parentheses x cubed plus natural log of 6 parentheses times the square root of x. So that is one function here and one function here. Okay, now don't let the natural log of 6 fool you. That is a constant, and when we do the derivative, it's going to turn into 0. Okay, so the derivative is you take the derivative of the first function, and you can mix it up however you want. This guy is obviously just switching it up. You can rearrange this because of the plus sign. Normally we would do this. You would do x cubed plus natural log of 6 times the derivative of square root of x plus the derivative of x cubed plus natural log of 6 times the square root of x. Okay, so I'm just going to keep it in the order that I would usually do this with. So this one you leave alone, so it's just x cubed plus natural log of 6, and then this one right here becomes 1/2 times x to the negative 1/2. Okay, so that's the derivatives. So first we set it up, and then we actually start doing derivatives. Okay, and this one I do the derivative first, and x cubed becomes 3x squared, natural log of 6 becomes 0. Okay, and then I just multiply and simplify. Okay, so square root of x times 3x squared becomes 3x squared times square root of x plus, now this one I'm going to treat it as 1/2, so 1's on top, so pretend there's a 1 here, the 2's on the bottom, and since this is a negative 1/2 power, it makes the square root of x go on the bottom. So x cubed plus natural log of 6 over 2 square root of x. Okay? Alright. Now the quotient rule is a little bit alike the product rule. Now the product rule, you could screw up the order in here and still be fine, just as long as you do the derivative first plus the function of the second plus the derivative of the second times the function that's first, or vice versa, you mix up the order. Okay, quotient rule, you can't screw up the order. Now it's not the quotient of the functions two derivatives, rather is described by the equation below, which is the derivative of the first times the function that is second minus the function that is first times the derivative of the second function divided by the second function squared. Okay, so this one right here, this one's going to get a little bit complicated, so just stick with me here. Evaluate the derivative of f of x squared plus 3 of x minus 2 tangent of x. Now this is all, sorry, let's click out. This is all one function, so this is going to be our f of x, this is going to be our g of x. Okay, so we go to the solution. Okay, so first off, we do the derivative of the first, which is x squared plus 3x minus 2 tangent of x, which becomes 2x plus 3 minus 2 secant squared of x times square root of x. Now when you're dealing with square roots of x, don't distribute, just kind of leave them as is for now. Okay, then we minus the first function times the derivative of the second. And as you guys remember, this turns into 1/2 times x to the negative 1/2. Okay, so we have our derivatives, we're all set. Now if you notice, when I looked through this, I go from square root of x to 2x, I went from 1/2 times x to the negative 1/2, and on the bottom I go from x to 2 at 2x to the 3/2. Okay, so what I did was I multiplied top and bottom by 2 square root of x. Now when I did that, this became 2x, this became just nothing because there's nothing there, and this one became 2x to the 3/2. Now that's what we want because it just makes our job a lot easier. Okay, now if you notice, there's a lot easier stuff to simplify. So here I would distribute the 2x to these three parts and get 4x squared plus 6x minus 4x times secant squared of x. And then I just subtract the second part. If you notice, there's going to be these first two, so 4x squared minus x squared becomes 3x squared. The 6x minus the 3x becomes 3x. And then I can't combine these two, so I just leave them as is, and I get something that's simplified and looks like this. Alright, it's a very gorgeous, elegant way to do it, and I highly recommend that when you do the product and quotient rule, try it out a couple times, work with it, and actually go through it. Okay. Alright, so once again, just follow these rules right here, and it should be a lot easier than what we just started out with, because that was a tough one. Alright, thank you very much. Oh, forgot the other part, which was the higher order derivatives. Just almost forgot that. Okay, now let's say we actually had some kind of function. Let's say it was, okay, so this is going to be the higher order part. So let's say we had f of x equals 5x cubed minus 3x squared plus 10x minus 5. Okay, let's say we had something like that. So if we do the derivative of first, so it'd be f prime of x equals 15x squared minus 6x plus 10, because then we would have 0 because that's a constant at the end. Okay, now if we wanted to do the second derivative, okay, that's going to be f double prime of x, and we just do the same rule. We just treat, now we take the derivative, when we're doing the second derivative, you treat the first derivative as just your normal function, and then you just do the derivative. So this becomes 30x minus 6. Okay. Alright, now I do want to take a look at that in Desmos. So let's go up here to Desmos, our wonderful friend. Okay, so y equals, let's take a look at the first function, 5x cubed minus 3x squared minus, or plus 10x minus 5. Okay, and we've got something funky that looks like this. Okay, something that looks like that. Now if you notice, it's increasing really fast, and then it kind of slows down, and then it gets here and it starts increasing again. So let's take a look at the derivative. Y equals 15x squared minus 6x plus 10. Okay, now here's something pretty unique. Alright, so as we're working through here, if we take a look, let's drag the graph over here. Okay, as you can see, we get over here, and if we zoom in, yeah, it's kind of hard to see. So, okay, if we kind of go work through here, if you notice, the graph of the second one is looking like this. Now, let's say that this was position. Okay, let's use physics to just connotate where the second derivative comes from. Okay, the first derivative is going to be velocity. Okay, so we're increasing here, increasing, and then it looks like we kind of slowed down, and then all of a sudden we increase again really fast. And right about here, we cross into the positive x form. Okay, now right here, if you notice, it's negative. It has a negative downward slope, and then all of a sudden right about here, which is about 0.2, and I bet you if we find 0.2 down here, we'll find a similar type, well, not the same number, but we'll find a point right here. Okay, so it's really kind of cool how this stuff works. But anyways, right about here it turns and it goes back up because now we're increasing faster. Okay, so higher derivative functions are actually explaining another step, and this is actually velocity. So if this is position, this is velocity. Now if I do the second derivative, which is going to be y equals 30x minus 6, okay, so we just take a look at it. Alright, now this is going to be kind of hard to see right here because it's really close together. Let's do a different function. You know what, I'm going to go ahead and do this. So y equals 3x squared. If we go lower level, you'll understand this concept a little bit better. Plus 4x minus 5. Okay, so here's our function. It just looks like this. Alright, now if I do the derivative, y equals 6x plus 4. Okay, I get something like that. That's the first derivative. And if I do the second derivative, I'm going to get this. Okay, so let's take a look at these first two. Alright, so my graph, it appears to be decreasing, but then it's slowing down, and then all of a sudden it gets positive, and it starts increasing. Okay, now if you notice right here, look at the second graph. This is my velocity. Okay, it's not a coincidence that those both are points that are important. Okay, so what's happening is on the second graph, which is my velocity, I'm going from a negative velocity, and then all of a sudden I'm a positive velocity because I'm above the y-axis. Okay, which makes sense because I'm going from negative velocity, slowing down, then all of a sudden I'm positive right here, and then I get positive from here on out, which makes sense why this graph is going up this way. Okay, now if I take a look at the second graph, or the third graph, the second derivative with the first one, this one's increasing at a constant rate. So this is usually reserved for acceleration. There is no acceleration, there's no deceleration, it's just there. I'm constantly going at this speed of 6 units per second. And so what the third derivative